so let's go through this problem. What we need to recognize is the types of functions. We don't really have that many. Um, there's the power function, which is x to an n. We have logs, which are relatively simple to identify because they have like log in them, or they might be natural log, but we can identify them. And then another type of function we have is exponentials, which is a number to the variable. So the two that we need to be able to distinguish between is the power, which is a variable to a number, and an exponential, which is a number to a variable. So in this case, we need to look and see what we're looking at. So we go over here and we say, okay, what do we see? I have a number, e, even though it's a letter, e is really a number, to something with variables. So therefore, this rule is an exponential function. So what is the derivative rule for exponential functions? Well, you copy it down exactly as it is, just how it looks, right? Then you scratch out the base, and now it's a new problem. So we say to ourselves, all right, looking at this, what kind of function do we have? Well, once again, we have a number. I'm going to get rid of the color so I can use that here. We have a number raised to a variable. So what function do we have? Oh, look at that. It's another exponential function. So what do we do for exponential functions? You copy it down just like it is. And now, since this is base not e, it's times the natural log of the base, so it's times 9. And that's actually true with the e as well, because this would be times the natural log of e. Natural log of e is 1. So it's really just one rule. Same rule. All right, so we scratch out the 9, and we say now what's left? X squared plus 2x plus 4. What kind of function is this? This is variable to a number, so that's a power rule. So now times 2x plus 2 plus 0, and then we don't really need the plus 0. All right, hope that helps.